electricity. Um, Suppose I have two spheres. Sphere A is positively charged and sphere B is negatively charged. And if I connect the two spheres by a wire, copper wire, then electrons will flow from sphere B to sphere A. Rate of flow of electron is electric current. This means how much coulombs of electrons are flowing in 1 second is electric current. This definition of electric current is sufficient for O level, but in high level physics we define electric current as the rate at which electrically charged particles pass a point in a circuit. Electric current is measured using an ammeter. Ammeter is a device for measuring current. The symbol of ammeter is this. Ammeter is always connected in series with the component through which the current is passing. We always connect ammeter in series. It's very important. Series is very important. Unit of current is ampere or milliampere, and the formula is I is equals to Q upon T. I is current in amperes, Q is quantity of charge in coulombs, and T is the time in seconds. Let me illustrate one example, and this example is from past year paper. A lightning flash carries 40 coulombs of charge and lasts for 5.0 millisecond. What is the current in the flash? This 40 coulomb is your Q and 5 ms is your time. This m stands for milli, which is 10 raised to the power minus 3. So if you allow me to write, it's not necessary, but let me point out, Q is equals to 40C, time is 5 millisecond, this means 5 into 10 raised to the power minus 3 seconds. You have to find current, you have to find I. The formula you have is I equals to Q upon T, 40 divided by 5 into 10 raised to the power minus 3, and this you can simplify. So this is 8000 amperes. To make current flow, a potential difference must be present between 2 points in the circuit. We need potential difference to make electrons flow. This potential difference is provided by a power supply or a battery. Definition of potential difference is given in red. Potential difference is defined as the energy or work done per unit charge. Potential difference is measured in volt. Volt is the unit of potential difference. And this is the symbol for voltmeter. Voltmeter is a device which is used for measuring potential difference. We connect voltmeter always in parallel to the component in a circuit. Connecting in parallel is very important. And you have to note one thing, that potential difference and voltage are same thing. And in short form, you can learn voltage is joules per coulomb. And as I pointed out before, that potential difference is defined as the energy or work done per unit charge. Energy is measured in joules, charge in coulombs, so you can learn voltage is joules per coulomb. Also, in potential difference, electrical energy is converted into other form of energy. There is another important term connected to this, that is EMF. The term EMF is used when charges gain electrical energy from a power supply or a battery. Definition of EMF is electrical energy produced per unit charge passing through the source. Usually battery is the source of EMF, electromotive force, because the battery provide the work done per unit charge required. You can also learn EMF as joules per coulomb. That is why unit of EMF is volts. Yes, in EMF, other form of energy convert into electrical energy, while in potential difference, electrical energy convert into other form of energy. But in EMF, other form of energy convert to electrical energy. Resistance. Resistance is the opposition that the electric current experiences while it is moving across a component. The greater the resistance, the smaller the current for a given potential difference. And you can define resistance as potential difference over current. The unit of resistance is ohm. This is the symbol of ohm. It's a Greek letter sigma. Omega. Symbol of variable resistor is this. There is a rectangle and the arrow is over there. Symbol of fixed resistor is this, a simple rectangle. Power is rate of doing work or the rate at which energy is transferred. Power is measured in watts, and the formula which we usually use for power is P is equals to VI. V is potential difference, I is current, but I have listed 7 important formula. First of all, we have seen before Q is equals to IT, which came from I is equals to Q upon T. P is equals to VI. You have to learn this is the formula for finding power. E stands for energy, is charge into voltage. Also energy equals to VIT. Also energy equals to I square RT. Another formula for power is I square R. Another formula for power is V square over R. I have explained all these things. Q stands for charge, which is measured in coulombs. I is current, which is measured in amperes. T is time in seconds. E is energy measured in joules. Potential difference, V is potential difference, which is measured in volts. R is resistance. and unit of resistance is ohms. The symbol for ohm is this omega sign, which is a Greek letter. Ohm's law. Ohm's law states that the potential difference across a metallic conductor is proportional to the current through it, provided the physical conditions like temperature do not change. We can also say current through a metallic conductor is proportional to potential difference, and provided the physical conditions like temperature do not change. If you allow me to write it mathematically, I will say potential difference is proportional to current I, or if I write equals to, R is the constant of proportionality, and the equation will become V equals to IR. This is Ohm's law. V is potential difference measured in volts, I is current measured in amperes, R is resistance which is measured in ohms. If you draw a graph between potential difference and current, you will get a straight line. Or you can take it this way, that all resistors obeying Ohm's law will follow this straight line. V equals to IR is Ohm's law. The following graphs illustrate variation of current as the voltage across a component is changed. So there are 3 IV graphs which you have to consider. First of all, for resistor following Ohm's law, you get a straight line. In IV graph, I is on your y-axis and V voltage is on your x-axis. I is current, V is potential difference or voltage. So all ohmic conductor follow a straight line. But if you have a filament lamp, resistance of filament increases when temperature rises, and in case of filament lamp you will not get a straight line. In IV graph you will get a curve of this form. In case of diode, the IV graph look like this, as I have shown in red. Resistivity for a conductor of length L and uniform cross-sectional area A, while resistance is R, we can say resistance of a conductor is directly proportional to length of the conductor. Resistance is inversely proportional to cross-sectional area of the resistor. And if you combine these two, you will get R is proportional to L over A. And if you write equals to and constant of proportionality rho, then your equation will become this. Well, rho is your resistivity. You can also separate rho. It will be RA over L. The unit of resistivity is ohm meter. Then we come to practical electricity. In our household, main electricity has 3 wires. Live wire is brown in color, neutral wire is blue in color, and earth wire is yellow-green. You can see fuse is connected to live wire. Fuse is always connected to live wire. Fuse is a thin wire made up of thin wire which melt when current exceeds certain limit. So this color combination is important. You also need to know that live wire provides current to the circuit, and voltage of live wire is the same as the voltage of main supply. If the supply is of 220 volt, then the live wire is also at 220 volt. Neutral wire provides return path to current in the circuit, and voltage of neutral wire is 0 volt. Earth wire is important in earthing, and earth wire ultimately is connected to the outer casing of an appliance. So in case if there is a leakage of current, then the current, instead of giving any person electrocution, will go to the earth through this earth wire. Voltage of earth wire is 0 volt. Fuse is another safety device. It is used to protect electric circuit against excessive current. It is always connected to live wire, as we have seen before. Symbol of fuse is this. Earthing is this arrangement of earth wire which is a safety measure. So earthing is also a safety measure which prevent electrocution. And always remember that earth wire is connected to casing of an electric appliance, and in case of leakage of current, the fuse melt and the current stop flowing, and this prevent electrocution. Example number 2. This is also a past year paper question. The information on the back of a television is shown. This is the voltage. This is the frequency of alternating current. And 0.6 ampere is the current. Which fuse provide the best protection for the circuit? Always remember that the fuse is always slightly above the current which is flowing through the appliance. So if you take 0.5 ampere, this is not correct because it is less than 0.6 ampere and the fuse will not work. 13 ampere is again too big. 5 ampere is also too big, and 1 ampere is close to 0.6 ampere, slightly above. So this is the best choice. Example number 3. A simple wiring diagram for an electric cooker is shown. And you can notice live, neutral and earth wire. The question is, why is there a wire connecting the metal case of the cooker to earth? We have already seen that it prevents electrocution and it prevents electric shock. So let's see the choices. A, it improves efficiency of the cooker. It's not correct. B, it prevents the metal case from becoming too hot when the cooker is left on. This is also not correct. It reduces the risk of an electric shock if the wire touches the metal case. Yes, this is correct. There are some electrical components which are important. Thermistor. Thermistor is heat operated resistor, and resistance of thermistor always decreases as temperature rises, while in other resistor, when temperature increases, the resistance increases. But thermistor is different. Resistance of a thermistor decreases as temperature increases, and this symbol of thermistor is important. LDR, or light dependent resistor, the symbol is important. Resistance of LDR decreases as intensity of light increases. Diode allow current to pass in the direction of arrow, and this is the symbol of diode. And you also have to learn this. It allows current in the direction of arrow, which means in this direction. LED, or light emitting diode. Light emitting diode allow current to pass in the direction of arrow, so this will also allow current to flow in this direction. Series combination of resistors. You can see three resistors, R1, R2, R3, connected in series, and all three are connected through a battery of V volts. Current always flow from positive to negative, and this current is conventional current. Actual current flow from negative to positive, but in physics you always take conventional current, which flow from positive to negative. So current I is coming here, and since there is only one path for the current, so the same current is flowing through three resistors. That is, I current is flowing through each resistor. Since three resistors are connected at different places to the battery, I can say R3 resistor is close to negative and R1 resistor is close to positive, while R2 is somewhere in between. So the voltage will divide, and V1 is the voltage of R1, V2 is the voltage of R2, V3 is the voltage of R3. And you have to learn that V, which is the voltage of the battery, will be equals to sum of individual voltages. And also note that the same current I is flowing through each resistor. If R is combined resistance of the three resistor, then combined resistance is equals to sum of individual resistances. Parallel combination of resistors. The three resistors R1, R2, R3 here are connected in parallel to the battery. The three resistors are connected to the same point of the battery, so we can see that potential difference of the battery is the potential difference of R1, potential difference of R2, and potential difference of R3. So R1, R2, R3 have the same voltage, that is the voltage of the battery. But current has three different paths. I1 current will pass this way toward R1, and I2 current toward R2, and I3 current toward R3. Since the routes are different, paths are different, so the current I coming out of the battery will divide in three parts. So the total current coming out of the battery is equals to I1 plus I2 plus I3, and if R is the combined resistance of all three resistors, then 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is also an important result. Now come to example number 4. In the circuit shown, the potential difference across the 4 ohm resistor is 6 volt. Sorry, it's 8 volt. So if it is given to you that this 4 ohm resistor has 8 volt, and we know that this voltage in case of series divide in between the resistors, so we can say that for 2 ohm it will be 12 minus 8, which is 4. So simply the answer is 4 volt, because this 12 volt divide in between 4 ohm and 2 ohm resistors, and since 4 ohm voltage for 4 ohm 8 volt is given to you, so you can easily find out the voltage of 2 ohm resistor. Example number 5, it's a past year paper question. Figure 7.1 is the circuit diagram of a circuit set up by a student. The student uses 3 cells, each of electromotive force EMF 1.5 volt. The cells are connected in series as shown. State the name of the component P. Now component P is light emitting diode. We have already seen this in the notes, and or you can write LED. State what is mean by part B. State what is mean by electromotive force of a cell. I have already given this definition in my notes, and this is joules per coulomb, or you can refer my notes, but that just to recall. And this is energy per unit charge. But go back to my notes which I have given in this video. Part C. The student expects the reading on the voltmeter to be 4.5 volt. The actual reading is 0.2 volt. Suggest 2 reasons why the voltmeter is much less than 4.5 volt. We have to go back to this diagram. Each cell is of 1.5 volt, and if I connect 3 cells in series, then this is the correct diagram, and if I connect 3 cells in series, my resulting voltage is 1.5 times 3, which is 4.5 volt, and this is what the student is expecting. But there are certain flaws. You can notice that this cell is wrongly connected in the circuit. It's supposed to be this. This is one reason one cell is wrongly connected. And the second reason is this, that this voltage of 4.5 volt that we are expecting, it's not actually 4.5, divide in two components. One is lamp and the other is LED. And the examiner is asking about this voltage of the lamp. So since the voltage divide between P and lamp, so again 4.5 volt is not possible. So what is the answer? One cell is wrongly connected, and yes, and P also has some voltage. This will also take some voltage. Part D, in the space below, draw 3 cells connected in parallel. So these are 3 cells connected in series. The 3 cells connected in parallel. So you simply have to draw 3 cells. So this is the positive end, this is the negative end of a cell. One advantage of connecting cells in parallel. Remember, in devices or appliances, we have cells in series, not in parallel. But is there any advantage of putting these cells in parallel? And let me point out, suppose in this situation, if suppose the voltage in each cell is 1.5 volt, then if you connect 3 cells in series, you will get 4.5 volt. But if you connect 3 cells in parallel, your output voltage is 1.5 volt. So is there any advantage? Yes, there is one advantage, that cells last longer. Although the voltage is 1.5 volt, I'm putting a situation over here. Suppose one cell is of 1.5 volt, then the output voltage of 3 cells connected in parallel is 1.5 volt. But the advantage is this, that the 3 cells last longer. Example number 6, figure 8.1 shows part of a circuit containing 3 resistors X, Y and Z. The resistance X and the resistance of Y are each 10 ohm. The current through X is 0.3 ampere. The current through Y is 0.2 ampere. Calculate the potential difference across Y. Since you know the resistance, you know the current, you can apply Ohm's law. V equals to IR, and I is 0.2 and resistance is 10. So the potential difference across Y is 2, or to 2 significant figure, it will be 2.0 volt. Calculate the current I in resistor Z. This I is required. You can see 0.3 ampere is coming here. So it will divide in two branches. One is 0.2, so this will be 0.3 minus 0.2, and this will be 0.1 ampere. Explain in words rather than by calculation how figure 8.1 shows that the resistance of Z is larger than the resistance of Y. Use the idea about potential difference and current in your answer. See, both Y and Z have same potential difference because they are connected parallel, and 0.1 ampere is passing through Z, while 0.2 ampere is passing through Y. So we can say the resistance of Z is greater because lesser current, that is 0.1 ampere, is passing through Z compared to Y. You have to give 2 points. No, it's not specified, but there are 2 points. First of all, both Y and Z have same potential difference, and smaller current is passing through Z. As I pointed out, 0.1 ampere is passing through Z and 0.2 ampere is passing through Y. So since a smaller current is passing through Z, this means that Z is offering greater resistance. Now you have to find the total resistance of the resistor X, Y and Z. So first of all, you have to find the resistance of Z. You can use V equals to IR, and R is equals to V over I. Your potential difference of Y is 2 volt and Z is in parallel, so Z also has 2 volt. Current entering Z is 0.1, so this is 20 ohm. So the resistance of Z is 20 ohm. So first of all, you have to solve these two, which are connected in parallel. So 1 over R is equals to 1 over 10 plus 1 over 20. And if you take the LCM, this will be 3 over 20. So this R is for parallel two resistors. This is the combined resistance of two resistors connected in parallel. At another one, X is connected in series to this. So for the total resistance, you will add 10 to 20 over 3, and this will be 50 over 3, and if you simplify it to 3 significant figure, it is 16.7 ohm.